So let's move on to question 2 from the Emission Spectra test that we took on Friday, November the 15th. We're told that we have a green laser that has an emission wavelength of 540 nanometers, and its power is 18 watts, which is a joule per second. And we want to know the number of photons that the laser emits in 5 minutes. So we put all of this together. We can first of all convert minutes to seconds. Which is 300 seconds. Once we have 300 seconds, and we know that the power is 18 joules per second, we know the power of the laser is 5,400 joules. If you remember in class, when we were calculating number of photons, we took the total energy, which we now know is 5,400 joules, and we divided that by energy per photon to equal the number of photons. This is the delta E that we compute. That will be hc over lambda per photon. So doing the simple math will give us the number of photons. So the next thing we need to do is to compute hc over lambda. H is 6.63 times 10 to the minus 34 joule seconds. Of course, C is 3 times 10 to the 8 meters per second. And we're dividing this by 540 nanometers, which is 5.4 times 10 to the minus 7 meters. Should always take a moment to see what units we're left with, because the meters cancel and the seconds cancel, and this will leave us with a joule per photon. So we quickly need to calculate what the joule per photon is. Again, remember to use parentheses in this calculation. And then we'll divide it by the wavelength. And I obtain an answer of 3.683 times 10 to the minus 19 joules per photon. So putting this all together, the number of photons is equal to 5,400 joules divided by, remember put parentheses, 3.683 times 10 to the minus 19 joules per photon. And now all I need to do is simplify. And when I do this, I obtain an answer of 1.466 times 10 to the 22nd photons. And this is the solution to test question number 2.